So, hello everyone. My name is Kanchan Dikshit, and I am working as an assistant professor in the Department of Computer Science and Engineering in ABES Engineering College, Ghaziabad. So, today I am going to discuss about the deadlock. What is deadlock? What are the conditions required for deadlock? And what is resource allocation graph? So, you can see in this picture that there are several cars, but no car will be able to move forward uh, because of some other cars. So in the scenario of system, this is the same concept for the process. So there are several processes, but any process is not able to move uh, towards the execution or finalize the execution because of some other process. So this is the condition that is called as deadlock, where two processes are conflicting for the same resource at the same time, but both of them are not being able to get that resource. So this situation is made up with the help of mutual exclusion. So this is a big problem in process synchronization when two processes are mutually uh, trying to access a particular resource. So let us take an example. Suppose there is process P1 and it is requesting for the resource R1, but resource R1 is allocated P2 and P2 is waiting to get the access for source R2 when R2 is being allocated to P1. So simultaneously, both of the processes P1 and P2 are waiting for each other to get or to complete its execution so that they can finalize their resources by accessing each and every resource, and they can complete their execution. So this is deadlock. There are some basic facts about resources. So if we say like what are the resources? In terms of a system or a process synchronization, we can say input output devices or like memory, CPU cycle and locks. I'm just taking these four examples to define resources. Now, if there is any resource, suppose there is any file that is R. Now there are two processes P1 and P2. They both are trying to get access of resource. But for that they need to apply the lock over this, because this is the critical section. When the resource R will be allocated to any process, no other process can utilize it or can get the access of resource R. So this is the situation that is called as mutual exclusion. Okay. So we can say this is the mutual exclusion problem where the resources are non-shareable and one process at a time can access the resource. So this is all about mutual exclusion and resources. Now, if any process wants to access the resource, first they need to request for the resource, then it will be approved, then it can use or access the resource. After that, the access will be removed or the resource will be released from the process for other processes. Now, what is resource allocation graph? Resource allocation graph is a graph that represents the resource allocation. That means suppose there is source R1, source R2 and resource R3, right? There are two processes. P1 requires resource R1, R2 and P2 requires resource R2, R3 to get complete their execution. So R1 is already allocated to P1 and R2 is already allocated to P2. P2 is requesting for R3 and P1 is requesting for R2. So in this we can see like resource allocation graph is having vertices in the form of process vertex and resource vertex, right? So process vertex are represented with the help of circle and resource vertexes are represented with the help of square or rectangle. Now it comes to edges. There are two types of edges, requesting edge and allocated edge. So requesting edge is the edge that is pointed towards the resource. That means if any edge is directed from process to resource, right? So that will be considered as requesting edge. And allocated edge is the edge that is directed from resource towards the process, right? So this is the example of resource allocation graph. Now, what are the conditions for deadlock? There are total 4 necessary conditions which are listed here. But when all of these conditions will be true, then only we can say there is a deadlock, right? So first we will go through mutual exclusion. What is mutual exclusion? In mutual exclusion, we can say there are some non-shareable resources. So at a time, only a single process can use the single resource. That means if there is any resource R, at a time it can be allocated to P1, right? If P2 is requesting for it, then this cannot be allocated to P2 until P1 completes its execution, right? So this is mutual exclusion. Now hold and wait. What is hold and wait? In hold and wait, we can see P1 is having the request on R1 and it is having R2 that is allocated to it. But R2 is being requested by P2 and P2 is having the allocation at R, right? So in this we can say this is the request edge, this is the allocated edge, this is also the allocated edge, this is requesting edge. So here we can see that P1 is holding the resource R2 and waiting for the resource R1. In the same way, P2 is holding the resource R1 and waiting for the resource R2. So this is the condition of hold and wait for deadlock. Now, no preemption. What is no preemption? In the resource allocation graph, we have already seen that P1 has R2 and R2 is required by P2. But this R2 resource cannot be taken back from P1 until P1 completes its execution. So this is the condition of no preemption. No preemption means until a process cannot complete its execution, no resource can be preempted from that process. We cannot take any resource from the process if the completion of the execution is not done. Now, circular wait. What is the circular wait? For this, again, we need to go for the example. Like there are two resources and two processes. So, if we make a graph roughly, then P1 is waiting for the completion of P2. And P2 is waiting for the completion of P1. Right? So circularly, two processes are in a wait. So this is never going to end. The wait time is infinite. So this is the last condition of deadlock. Now the next topic is deadlock handling. So deadlock can be handled before deadlock occurs or after deadlock. Before deadlock, we can prevent it, we can avoid it, but after deadlock, we need to detect it, and as soon as it is detected, we need to get the recovery from deadlock. So, this is the reference, and thank you so much.